Dear students, so in the last class we discussed about queuing theory. So what is queuing theory? Queuing theory is a quantitative technique which consists in constructing a mathematical model for various type of queuing system. So in different times in life we'll have to face a queue. So how we can reduce its adverse impact using a mathematical model. That is what the queuing theory talks about. Okay, so all the characteristics of a queue is mathematically represented in a queuing theory using Kendall-Lee notation. Okay, so today in today's class we will discuss about Kendall-Lee notation. So what is Kendall-Lee notation? How we can use it for solving problems, correct? Okay, so basically Kendall-Lee notation, it is depicted using this particular formula, that is A or B or C is to D or E or F, right? So this is called Kendall-Lee notation. So for each and every term, like each and every letter, there is a particular meaning. So here A represent input or arrival or inter-arrival distribution. B is representing output or departure or service distribution. C is service channels. D is service discipline. F is calling source, and E represents the maximum number of customers allowed in the system. So here we are talking about a queue. So when you are in a queue, for example, you imagine yourself standing in a queue to pay the bill in a supermarket. Okay, so in that case, A is representing the input or arrival or inter-arrival distribution. That means a customer is coming in and he is in the queue. That input is represented by A. Then B is representing the output or departure or service distribution. That means a person is paying the bill, he is taking his items and just leaving from the supermarket. That particular point, that is the output or the departure or service distribution. Then C is the service channel. So that means where the service is provided, right? So whether if it is a supermarket, how many number of counters are there, such things are represented using C. Then D is service discipline. Service discipline means, as we have already discussed, service discipline represents how that service is being offered. For example, whether it is first come first served, last come first served, or priority wise, or is it just the random wise service providing. So such things is represented using letter D, that is service discipline. Then F is the calling source. Calling source means, suppose if it is a supermarket, then that is a calling source, or if it is a grocery shop, then that is a calling source. So it depends upon the on what the queue, where the queue is. Okay, and E is coming here, is representing the maximum number of customers allowed in the system. Normally this F and E using when we are using the MM1 notation, usually F and E will be infinity. So here F, calling source, and the maximum number of customers is considered either it will be finite or infinite. If the total number is not given, we can consider it as infinite. Okay, that we will discuss in detail. Okay, so here first one, that is input or the arrival or inter-arrival distribution, it follows different type of distribution, can be either of the 5 type. So the first one is M, that is Markovian distribution or Poisson arrival distribution. So it is a negative exponential service distribution. Usually in the problems we consider the input in as Markovian distribution or the Poisson arrival distribution. Okay, then type is deterministic or inter-arrival or service time distribution. Then Ergian or gamma inter-arrival or service time distribution. Then general independent distribution, and last one is general distribution. This can be either of these 5, but you don't have to bother too much. Normally in the question they will be asking only M or Markovian distribution. Okay, so here in this syllabus we will have to study only Markovian distribution. Then the next one is output or departure or service distribution. Again, as I told you, just like the input, this is normally considered as the Markovian distribution only. Then C, that is C is represented A or B or C. C is the service channel. It shows the number of servers. Normally in a supermarket you can see more than 1 counters there, but if you go to a small shop there will be only 1 counter for paying the bill. So in that case the number of or the service channel will be just 1. Okay, but in a supermarket there may be 3 or 4 counters. So depending upon that, the service C will be 3, 4, whatever is the number of service provided. Then D, that is service discipline. Service discipline, as I told before, it can be first come first served. It is also called first in first out. Then last come first served. Then service in random order. Then general service discipline or priority service. Okay, so it can be either of the type depending upon the system where we are working, right? Then the next one we will discuss is E, that is maximum number of customers allowed, right? So in the notation, the next part is E, that is maximum number of customers allowed in the system. It can be finite or infinite. Then the last one is calling source, as I told you, it can be finite or infinite again. Okay, so using example, we will discuss each and everything in detail. Now before going to the example, let me introduce some simples which comes in the Kendall notation. Okay, using these things we are going to solve problem. So here lambda represents mean arrival rate, mu represents mean service rate per busy server, rho represents lambda by mu. It is also called the utilization factor or the traffic intensity. Then n is the number of units in the system. Pn of t is probability of exactly n customers in the system at time t. That means at a particular time t, what is the probability of exactly n customers in that particular system. Then Pn is probability of exactly n customers in the system. You should remember there is a difference. Here Pn of t is at the time t. So time will be specified. Here there is no specific time. Okay. Then C is number of parallel servers. Then Ws represents the expected waiting time per customer in the system. WQ expected waiting time per customer in the queue. Again there is a difference. WS means expected waiting time per customer in the system. System means the queue plus the person who is getting served and again the person who has completed the service. So everything together represents the system. So here WS is talking about the waiting time per customer in the whole system, but WQ is expected waiting time per customer in the queue, only the queue. So now you should remember one thing. Now consider that, for example, here there is a queue, then here there is a server, this is server, and finally this is exit. Okay, after the service the customer is going out. So there are different customers standing in the queue. Okay, and one person is getting served by the server, and that person after paying the bill, for example in the case of supermarket, he is going out or he is exiting. So this whole thing, the whole thing is called the system. Okay, so here WS is talking about the expected waiting time in the whole process, fine, and WQ is expected waiting time per customer in the queue. So WQ is talking only about the queue, not the entire system. So you don't confuse with these two things. Then again similarly LS means expected number of customers in the system. That means the whole system we are talking about. And LQ is expected number of customers in the queue. So I hope this is clear. Okay, these are just some of the simples that is used in Kendall notation. Not Kendall notation, exactly the queuing theory. So we will be solving the problem using Kendall notation. Okay students, so now let's discuss Kendall notation using a problem. Okay, look at the problem. A self-service store employs one cashier at its counter. 9 customers arrive on an average every 5 minutes, while the cashier can serve 10 customers in 5 minutes. Assuming Poisson distribution for arrival rate and exponential distribution for service rate, find the following. The first one is average number of customers in the system, average number of customers in the queue or queue length, average time a customer spends in the system, and average time a customer waits before being served. Okay, so look at the question, how we will represent this using Kendall notation. So what is Kendall notation? Now if you take Kendall notation is A by B by C is to D by E by F, right? So here the input. So first what is given in the question? The last part of the question you need to be careful about the last part. Assuming Poisson distribution for arrival rate and exponential distribution for service time. So for arrival rate it is Poisson distribution. So you need to mark it as M. Then exponential distribution for service time. That is also marked as N. Now in the question it is given that self-service store employs one cashier, right? So one cashier means service channel is just one, right? Okay, the next one is service discipline. Nothing is told about the service discipline. When nothing is given, you need to assume it is first come first served. Normally, in case of any store, what happens when we are in a queue, the first person will be served first, right? So by default, we will have to assume this is FCFS if nothing is given, right? And again, you have maximum number of customers. So any number of customers can come into the store. So it is depicted as infinity, and again the calling source is also considered as infinity. So we can rewrite this as MM1 as to FCFS infinity by infinity, right? So this is our Kendall notation for this particular problem. Okay, now we are going to solve the problem. Now, what is asked? Average number of customers in the system. So, in order to find out this, so first we found that this is MM1 type of notation. So, for MM1 type, whenever it is coming as FCFS, when the service is having a discipline of FCFS and infinity, we use the following formula. There are so many other formulas as well, but these are the standard formulas for queuing formulas for MM1 Kendall notation whenever it is first come first served. Fine. So these are the basic formulas which you need to remember. According to the formula, WS or the waiting time in the system is equal to 1 by mu minus lambda. Then waiting time in the queue, WQ, is equal to lambda divided by mu into mu minus lambda. LS or the length of the system, which is the number of customers in the whole system, is equal to lambda divided by mu minus lambda. Then LQ is equal to lambda divided by mu into lambda divided by mu minus lambda. LQ is the length of the queue or the number of customers waiting in the queue. And rho or the utilization factor or traffic intensity is given as lambda by mu. Now, what is lambda? Lambda is arrival rate and mu is the service rate, which we have already discussed, right? So we need to find each and everything in order to solve this particular problem. Okay. Now look at the question. First one is average number of customers in the system. So average number of customers in the system is given by LS. So LS is equal to, what is the formula for LS? LS is lambda divided by mu minus lambda. So you need to write lambda divided by mu minus lambda. So this is the solution for the first subsection, right? Then the next one is average number of customers in the queue or queue length. It is given by LQ. LQ formula is lambda divided by mu into lambda divided by mu minus lambda. So this is LQ. LQ is equal to lambda by mu into lambda divided by mu minus lambda. Then average time a customer spends in the system, that is WS, which is equal to 1 by mu minus lambda. WS is equal to 1 by mu minus lambda. Then the next one is average time a customer waits before being served. That is the last question. So average time in the queue, right? Average time a customer waits before being served means before he is getting served means he will be in the queue. So that means it is WQ. WQ is equal to lambda divided by mu into mu minus lambda. Correct? So we have all these formulas with us. Now we need to solve this. Now before finding all this, first we need to know what is lambda and mu. Now when you consider the question, what is given in the question? A self-service store employs one cashier at its counter. 9 customers arrive on an average of every 5 minutes. So 9 customers are coming every 5 minutes. So arrival rate is equal to 9 divided by 5. Yes or no? So we get 1.8 customers per minute. This is your arrival rate. And what is arrival rate? That is lambda. Lambda is equal to arrival rate. Next, again, while the cashier can serve 10 customers in 5 minutes, 10 customers are being served in 5 minutes. So that means service rate is equal to 10 by 5, which is equal to 2 customers per minute. So this is mu. Mu is service rate. So lambda is equal to 1.8, mu is equal to 2. So what will be rho or traffic intensity? Traffic intensity, it is not asked in the question, but still we can find traffic intensity as lambda by mu, which is equal to 1.8 divided by 2, which is equal to 0.9 or is equal to 90%. Okay, now we can move on to the next part. That is average. What is asked? Average number of customers in the system, or LS. So for LS you have lambda divided by mu minus lambda. So now you know what is lambda, you know what is mu. So you can find LS. So LS is equal to lambda divided by mu minus lambda. Mu minus lambda. So what is lambda? Lambda is 1.8 divided by 2 minus 1.8. So you will get your LS as 9. So it is equal to 9 customers. Because LS is length, that is number of customers in the system. So that is equal to 9. So you can directly write here average number of customers in the system is equal to 9 customers. 9 customers. Okay. Then the next one is average number of customers in the queue or queue length, that is LQ. LQ, the formula is lambda divided by mu into lambda divided by mu minus lambda. So lambda divided by mu into lambda divided by mu minus lambda, which is equal to 1.8 divided by 2 into 1.8 divided by 2 minus 1.8. So you will get the answer as 8.1, which you can approximate as 8. So LQ is equal to 8 customers. Why customers? This is again the number of customers in the queue. So you can write average number of customers in the queue or queue length is equal to 8 customers. Okay. Then the third question is average time a customer spends in the system, that is WS. Average time a customer spends in the system, WS, is equal to 1 divided by mu minus lambda, which is equal to 1 divided by 2 minus 1.8, which is equal to 5 minutes, because it is waiting time, right? Average time is equal to 5 minutes. Okay. Then the last one is average time a customer waits before being served, that is how much he is there in the queue. This is average time spent in the system, and this it is average time spent in the queue. So WQ is equal to lambda divided by mu minus lambda, which is equal to 1.8 divided by 2 minus 1.8. So mu into mu minus lambda, right? So 2 into 2. WQ is lambda divided by mu into mu minus lambda. So 2 into 2 minus 1.8, which you will get it as 4.5 minutes. So average time a customer waits before being served is 4.5 minutes. Okay, I hope this is clear to you. Now, thank you students.